Welcome to the interview series. I'm Brendan Hong, a PhD economist and data scientist in consumer analytics. Today, my guest is Mr. Kai Jiang, who's a Devops engineer with a range of experience across banking and smaller companies like startups. He's going to give us a showcase of an application of DevOps in data science, and I'm going to ask him questions relating to a career in DevOps. Hope you enjoy it. Thanks for watching. My guest is Kai Jiang, who is a DevOps engineer. We've known each other since high school. Thanks for agreeing to do this.
You're welcome, Brendan. Pleasure.
It's great. I thought we could start off with maybe just a brief background about yourself, and then the format is going to be we'll do a showcase. Well, you'll give a showcase, and then we'll get into an interview, and we're targeting the aspiring practitioner and anyone who has general interest in the area of DevOps. The showcase is going to be application of DevOps to data science. But yeah, a brief background would be great.
Okay. So I'm a DevOps engineer working in Melbourne, Australia. I've been in IT since 2005. So what's that? 16 years. Initially started my career as a test analyst. And I guess along the way, most likely through debugging and maintaining of test environments, I kind of became more involved in production operations and eventually transitioned my way into DevOps probably over the last 3 to 4 years. I specialize mainly in the Azure space, and I guess for CI/CD, I've mainly been using Azure DevOps as the main platform. That's about it.
Oh, that's really good. How this partially came about, I guess, was I transitioned from academia to data and analytics maybe a couple of years back, and I remember coming across DevOps and not having much of a clue about it. So you were nice enough to show me some of the stuff you're working on, and I think, I guess you giving a showcase of similar kind of thing would be really helpful. So I know we did a little bit of prep beforehand, but what did you have in mind on what you were going to show us? I think it was a decent example, I guess.
Yeah. I'll just speak, I guess, briefly about what I'm certainly I've done a little bit of stuff in data warehousing in a previous life. I'm not particularly close to data science, but I'll have a crack at what I think DevOps can contribute to, I guess, data science initiatives or people's workflows. So, I guess in my mind, data science is all about taking in data from various sources, combining it, and then extracting information, insights, patterns and the such, and then pushing that out to a consumer. To me, that's basically a pipeline. So you've got input and some form of transformation, and then pushing stuff out. One of the key challenges would be, I imagine, there are various sources you can grab data from, and there are various, I guess, targets you can publish data to. And it's not necessarily always feasible to run it off, data scientist's local desktop. Maybe you need a bigger machine to do that, or maybe you need a farm of machines. So where, I guess, in my mind, DevOps can help is DevOps, at least in the CI/CD space, CI/CD being continuous integration, continuous deployment, in itself is a pipeline. So it can fit quite well by automating the data science pipeline. And that's what we're going to try and demo today, which then puts in place an automated, repeatable process that allows maybe a little bit of tweaking of the input, and then through the data science pipeline, output to a consistent location, so that the data can then be grabbed by whoever the consumer is. So I'm going to share my screen for a second. So you were kind enough to send me this blog earlier on, and essentially what Xavier here is, I guess, trying to demonstrate in his blog is a very straightforward training process. So go to his GitHub. He's got a couple of Python. He's got a Python trainer script, and he's got an inference script, which I presume takes the actual training, the train data, I guess, and then applies to some test data. So you can see that he's got a train data set and a test data set. What the blog essentially then goes on to do is talk about how he uses Docker to build an image that preps that does the training beforehand, and then essentially runs the Docker container and spits out some data, which runs the inference code and applies the train data set, or train. I don't know what the terminology is in data science, but the train model. Sorry. On top of the test data set. Everything that's being done here is, I would guess, being done on his desktop. And
okay.
one of the things that you can see in his project or repo is that the training data should sit with the repo, but the test data is actually is checked into the repo also, which then makes it rather inflexible, because you're going to have to update the repo every time to run the training model over some test data. What if, and this is a demo repository, so I don't think this is the intended, productionized workflow.
Yeah.
What if
this is an example where you wouldn't?
Yeah. So
rely
in this
on
case,
production.
what we want to do is, what if we could automate this whole process, but also allow us to adjust the incoming test data? And also he's got a bit of code here. He's got a bit, I think, a demonstration here that writes the. I think this is the test, the model from the test data set, the normalized test data set. What if you wanted to retrieve that information but write it out to a location for someone to consume? So that's what we're going to try and put together. And the input and output location, we're going to use a storage account inside Azure. So I've pre-created a storage account with basically two containers. One is an input container, and one is an output container. So we're going to put some files we're going to put a file into the input container, have the automated process retrieve that, inject it into the container, and have it run and spit out the output into the output container. Sorry, did you have a question?
Yeah, I was following, but I'm just wondering, on this screen resolution, it could be improved. Or you can kind of maybe zoom in for kind of the stuff you're showing. So I think this code is quite difficult to actually
That's
read.
Fine.
Yeah, no,
Yeah.
that's better. Cool.
you'll have a link to it in the description as well, right?
Yeah, we'll share this.
Yeah. So I mean, I think this is a pretty typical data science pipeline. You train some data, and then you run the trained model on top of some some new data to get you some results.
Right.
So as a step one, I've actually cloned his repository into my own repository to work off, and that's basically required for me to work off using Azure Devops. So we'll be using Azure Devops to automate that process. So in Azure Devops, there are these things, the concept of pipelines. A pipeline is basically a predefined set of automated tasks, and it can be for a variety of purposes. So in this case, we're checking out some data from GitHub. So we're checking out some files from GitHub. We're going to run a couple of commands to automate the building of the Docker container, and then the running of the Docker container. So that's what we're going to do as a step one. So,
and the Azure environment will kind of take care of, I guess, like the instances or environments needed to run those containers, or
we're going to be using basically hosted machines provided by Azure Devops. Azure Devops does allow you to use either machines hosted by Microsoft or build your own VMs and add them as agents to run your process on.
Yeah.
So go to GitHub.
Can you do anything about the zooming in again in here, or?
So
yeah, no, that's much better. Thanks.
So I've already actually authenticated with my GitHub account.
Yeah.
So I'm going to choose the GitHub repository. It's going to be checking out the main branch. So Azure DevOps allow you to. They basically have a graphic user interface for defining a pipeline, but also allows you to define pipeline using basically YAML format. So we're going to be going through the graphical user interface because it's probably more, I guess, it's a bit more visual and probably a bit more intuitive to people watching.
Sure. So
what we're doing now is creating a brand new job that we will run later. So I'm going to give it a name. Build, run. We've defined the source, which is from GitHub. And here's where we're choosing the agent pool. That's where we're going to be running the tasks.
Right.
We can define our own private agent pools, and then they will appear here. But for the time being, we're just using a default Ubuntu 18.4 machine from Microsoft.
Right, and that Azure Pipelines pool is a default kind of setting.
That's default. That comes with this particular service. So here, if we click Add, basically Azure DevOps has a bunch of inbuilt tasks, and there's a marketplace where people can publish tasks, and you can use those. If we look through what Xavier is doing here, so he's got everything all packaged inside the GitHub repo, and the first thing that he does is Docker build, which will basically initiate the Dockerfile. For those not familiar with Docker we're not going to go into it too much. Suffice to say that there is the way to build a Docker image is you define a Dockerfile, which is a set of instructions, and issue a command.
Can you zoom in a little on that one? Just, just to show what a typical file might look like.
Yeah, this is what a typical Docker file will look like. It usually starts from a base image using the from argument, and then basically you can define environment variables. You can run a couple of commands as overlays. You can basically start from a base image and then modify it. These are all commands to modify that image, and then once Docker's run through this list of tasks, it actually saves the state of that image into a new image. That's what
before moving on, I was just going to mention, so the reason you haven't had to specify Python and SciPy, all these libraries, is because you're using the base image. So if we went into and had a look at the base image, you'd see what all those what's built into that image. Is that right?
Yeah. So what's nice about Docker is there's I would say probably at this stage hundreds of thousands of publicly available images where people have prepackaged tools, or in some cases entire OSs, and made them freely available on the internet for people to use as base image. So in this case, I think this image probably already has at very minimum at least Python 3, and I'm guessing it's probably got Jupyter installed in there.
Right. As a notebook, if you wanted to roll your own, you could specify the things that you want, and that's not too painful either, is it?
It can be. If you're not familiar with it, it can be a little bit fiddly to tweak, especially if if you have syntax issues and whatnot. And if you've got a very large image, rebuilding it can sometimes take a little bit of time. What's nice is the way that Docker works. We're kind of going to a little bit more into Docker. For every command that is issued, it actually builds a layer. So basically what it will do is start from that, run this command, actually save the state immediately after running this command, and then run this command, save the state again, so that essentially if I ever modify, let's say, a line down here, it can actually pick up from a layer that's already been run all the way up to this point and then continue on. So it's quite efficient in that manner. Okay. But the end result is a Docker image that is saved on the machine that is being run and can then be pushed to what's known as a repository, where think of it essentially like a GitHub for Docker images.
And there's one kind of standard place for that, isn't there?
There are actually a number of standard places now. Most of the, major platform providers host, Microsoft have their own image repository. Docker Hub, obviously, is probably the original and the most commonly used. But these days, anyone can host, a large-scale image repository. It's essentially a image store. It's like basically a big database with a standardized API interface that Docker can interact with.
Right, and you'd expect companies to have their own kind of private ones running wherever they would like.
Most companies will most likely use a combination of public and private. Basically, I would imagine most of their, the first line will refer to public images, and then they will have their own Docker file definitions. And then when they finish running this process, where they publish to will probably be a private repository. And private repositories can enforce authentication and such for basically ensuring that it stays private.
Okay, great. No, that's good info. Don't want to hold you up. The
Yep.
rest of it.
So coming back to if you find this bit it goes too much into Docker, you can always edit it out. So what we want to do is first run this command, which builds a Docker image, and as part of building the Docker image, also trains the model using the training CSV file. So what we can do here is add a command line task. Now, the agent that we're running on already has a number of tools. In fact, it's got most of the industry standard tools already installed. That's one of the nice things about using a Microsoft provided agent. So if you were, for example, using our own private agents, it will be a vanilla VM, and we would have to ensure that, for example, things like Docker and Python and whatever else, Git, are all installed on that particular machine. Otherwise, when we run this command, it's not going to be able to find Docker if we don't have that. So what we're going to do is copy this command. Build image. And what we're going to do is we're just going to actually, I'm going to do the next step too. So once we build the image, the next thing is we can run the image. So you can see here that the build command writes to an image called Docker ML model using the Dockerfile.
Okay.
And the run command runs the image, and this is the command that we issue to the image. Essentially, we tell the image to execute this particular command. So what we can do is... So we can actually run this as multiple tasks, or we can run it as a single task, right? So in this case, all this is doing is running these two commands on this remote machine. So if we save it...
I guess in practice there's no real difference unless you kind of, like if it fails, it might be nice to see it broken up as separate tasks.
There are reasons why you would separate them out. One of the things is, let's say if you wanted this command to always run. So one of the things is for visual clarity. Every task that... sorry. So when we run the... Let me just put this into here. Let's save. Right.
So I guess you're now splitting it up into two.
I'm splitting up into two, and I'll show you what... So I'm actually running it. Now, what it does... So this is a log of it running.
That errored.
No, hosted. Purchased or...
It's hard to read, but
Okay, so I think the issue here is Microsoft has... So we've run into a little bit of a kink here.
I took you off the the happy path that you'd...
No, it's not that. I think we were always going to run into this. The issue is, I believe... So once upon a time... Let me try this again.
And this is the fun of doing demos, yeah.
I probably could have prepped this a little bit more. Once upon a time, Microsoft offered free agent compute, and what happens? So basically, it's a remote machine you can run things on, right? So you get free CPU cycles. What people started doing was, based on what I read, what people started doing was spinning up new Azure Devops projects and then running. Basically, they spun up like tens of thousands of those and started running Bitcoin mining.
Yeah,
on those free cycles.
Yeah.
And I think what's going on is now they actually require you to submit a request to get those to be able to run on this. Let me try it again. If that doesn't work, I might actually have to pause because I don't have a way to run this particular thing because I don't have a private agent on hand. Let's see if it works.
All right, let's take a pause on the recording.
Yeah. Okay.
Right?
Yep.
Okay, thanks. This concludes part 1 of interview 1, DevOps with Kai Jiang. This was the first half of the demo. Links to part 2, the second half of the demo, and part 3, the interview, can be found in the description.